Hey everybody, changing it up, the other side of my office. I know there's a little bit of a glare from the windows, but that's okay. It'll be fine. This is the high-level overview of Chapter 9, Linear Regression and Correlation. There was a lot in this chapter, and so I really do just want to kind of hit the high points, and then as you all, I hope, know by now, I'm always available for questions and more resources and more detail if you find yourself running regressions and doing this type of stuff in your day-to-day. So the first thing I want to mention, this comes up in the book kind of like throughout this chapter, but I want to mention it like very clearly on the front end. When we talk about correlations and we talk about regressions and we talk about anything that's not like purely econometric and causal, we are talking about associations and correlations. We are not talking about causing something causing something else, or anything causal. So this is kind of a pet peeve of mine. Once you hear people doing it, you can't like not hear people doing it when they use cause when they shouldn't. So be careful with your language around this, especially if you're talking about a correlation. So and a regression as well, but especially a correlation. So that's my tip of the day for that one. So this chapter outlines a lot that kind of falls in this regression analysis context. Is there an association between variables? How strong is that association? And can one variable predict another variable? So that's the testing for independence, that's the correlation, and that's the linear regression. So something worth mentioning is that there are a lot of different types of regression, many of which are much more complicated than what we're going to talk about here. But this is a linear regression. It's a straight line. So we are looking at either a positive or negative relationship between two variables in the form of a straight line. Right, there are other variables that can positively influence something until it starts to negatively influence it, like something like this. This is not that. Or some kind of exponential relationship. This is not that. This is just a straight line, like 8th grade math class. So, in the spirit of 8th grade math class, when we talk about looking at the independence of two variables, or how two variables are related, in this case, we're really just talking about the slope of the line. Right, so the formula that was put forth in the book is y equals alpha plus beta x, which is pretty standard kind of notation, notation around this. Alpha being the intercept and beta being the slope. But if you think about 8th grade math class, you think about like the slope of the line. The slope being the rise over run, change in y over change in x, or a different, like, same thing but different letters, is y equals mx plus b. If anybody has like middle or high school age kids or remembers this from their own time, this is the slope of the line. So that's what, that's kind of the level of detail we're going to get into here in terms of these relationships between variables. So if you did not like 8th grade math, I apologize. This is about as mathy as it's going to get for the summer. So the slope of the line, which is beta in this sense, is the change in y over the change in x. So that, said differently, is a 1 unit change in x results in some kind of unit change in y. And they give really good examples throughout the book about crime and poverty. That's a really good one. I would encourage you to actually read all of those examples like throughout, because it kind of takes the example through all of the different pieces of the chapter. So that's really good. But yes, a 1 unit change in x is associated with a something unit change in y. And I think something that's really important to know how to do is put these equations and these like mathematical things into actual words and sentences. So that's something I would encourage everybody to practice doing. Alpha is the intercept, so it's the value of y when x equals 0. So again, with this example about crime and poverty, if the poverty rate is 0, nobody lives in poverty, the incidence of crime is 210. So I don't know if that was 210 incidents per 100,000 people, I think maybe it was, or whatever it is. But when x equals 0, alpha is the answer to the problem. Again, I know there's kind of a lot in this chapter, like I said, so this is really just meant to be like the high points. So yes, so to follow that example a little bit further, a 1 unit change in the percent of people in whatever area living in poverty is associated with 25 additional crimes. Okay, so if you think about the 1 unit change in x and the related change in y, you can kind of say it the way I just say it. So again, I think something that was really valuable that I learned in my bajillion years of graduate school is how to do that, how to read a table and say the table using words, versus just kind of like putting a table on a paper and saying like, here it is, here are my results. Okay, so the slope of the line, the beta, is going to be positive or negative, right, depending on the direction of the relationship. And it's between -1 and 1. So you will never have a slope that is higher than 1 or lower than -1. So an example of something that has a positive slope because the relationship is positive is something like educational attainment and health. Those with more degrees are, in general, in the main, healthier than those who do not, right? A negative relationship would be something like educational attainment and your likelihood of working at McDonald's, right? So the more education you have, the less likely is, unless it's like a terrible economy or something, that you work in fast food. A positive association, again, would be the more education you have, you, on average, the healthier you are. Again, all of these things are related, but they are not causal, right? Having a PhD does not cause you not to work at McDonald's. Like, something terrible could happen and I could lose my job here and I could end up working in fast food. So one does not cause the other, one is associated with the other, and I'll probably say that like 10 more times. The book gives some examples of other ways to graphically put your data in just different kind of graphical figures to see what it looks like a scatter plot and a box plot. That's all well and good, but and if you have software, even just Excel, to help you do that, that's fine. I have actually never really found that to be useful. I think that's more indicative of my learning style than it is anything else, but I don't think the scatter plot or the box plot is always super useful. But a scatter plot can show you if your data do not seem to have a linear relationship to each other. So if it looks like the data are kind of like this, as they are in the book, or something like that, maybe a linear regression framework is not going to work. But beyond that, you don't really need to spend your time doing box plots and scatter plots and stuff like that. The book mentions outliers and extreme values. Those are really important to think about because really extreme values can skew everything, right? So I gave some examples a couple weeks ago in some chapter about how if you're looking at people's income and you include somebody like Bill Gates or somebody like Bill Haslam or whoever, that can kind of skew the average. The same is true when you're looking at these relationships. If you have observations that are way out there, they're going to skew what the relationship between the two variables look like. So to use this example of crime, if you think about a city that's kind of notorious for having high crime, Detroit, Newark, St. Louis, these cities that kind of get a bad rap for having a lot of crime, they could be considered outliers or extreme values in these types of analyses, and they can kind of make lead you to make false associations between the two variables if you have these really extreme values. So that's just something to be aware of. You can choose to get rid of them. You can choose to keep them in. The book makes mention of residuals and residual errors and how you want to minimize those, which you do. I think the name of the game here is really just document. If you have 6 or 7 extreme values and you drop them, you need to have at least a footnote or something in whatever it is you're doing that says any value higher than X was dropped, or any values that were lower than whatever were dropped, just so people know what you're doing and you don't manipulate the data in ways that are inauthentic or that kind of skew your findings in a bad way or in the way you want it to be or something. You need to be transparent about all that. Let's see what else. I guess we can jump right into the correlation piece of it. And basically what a correlation is, it will tell you is how strong the association is between two variables. So what we just talked about in terms of the slope and the intercept and all of that is whether there is a relationship, and the correlation will tell you how strong that relationship is. So the book outlines how you actually calculate a correlation using the slopes of the two variables and things like that, and that's probably as extreme as you would need to get with this. I think in terms of correlations, you don't necessarily need to be calculating them, though it doesn't hurt. You just need to know what they are and what they mean. And again, this is not causal, right? You often hear correlation, not causation, or association, not causation. That's very true when you think about these correlations. And if I can find it, I'm sure you guys might know what I'm talking about. If you look for the spurious correlations website, an increase in the number of ice cream cones sold is positively correlated, positively associated with like the number of oil changes you need in your car or things like that. Just things that don't make any sense that like statistically they do have a positive relationship, and so people will kind of make assertions like getting oil changes causes you to eat more ice cream. Eating more ice cream causes you to get more oil changes in your car, which is crazy when you say it out loud. But that's just kind of something to think about when you think about about correlations. So the book talks a little bit about the R-squared value, which is basically just how well one predicts the other. So if you're running a regression, you get an R-squared value of like 0.6. That is to say, again, using this in a sentence, 60%, 0.6, 60% of the variation in Y, your dependent variable, is explained by X, your independent variable. That gets a little more complicated when you have a multivariate regression rather than just two variables, one on either side. You have, your dependent variable, and then you have 6 or 7 on the right side as X's. That gets a little more complicated, but that's what an R-squared is. This percent of the variation in my outcome and my Y is explained by this 1 or 2 or 3 or 4 or whatever set of variables on the right side of the equation. The book talks a bit about the inferences around regression and the assumptions and the possible biases. I would check that out. That is kind of dry reading, but that's really fundamental when you're doing stuff like this to know what you kind of can and can't or should and should not be doing. Just make sure that they talk a little bit about this, that your variables are independent of each other. If you run a regression or you're doing any kind of analysis and the variables are related, that will screw everything up. So that's kind of another lesson for another time, but just really make sure that the variables that you're using are not related to each other. And I'm trying, like, a lot of times you can use like income, and you can use like Pell eligibility, right? That's not a great example, but Pell eligible and income are going to be somehow confounded. Those are not independent of each other. So that can kind of mess up your results if you're including Pell eligibility and your family income in some kind of regression or in some kind of analysis that you're doing. Similar to the extreme values, if you have missing values, that can mess stuff up as well. There's something called omitted variable bias, which is exactly what it sounds like. You will bias your results if you don't have what you really should have in your regression. Some of that is just kind of trial and error, and some of that's just a judgment call. But omitted variable bias is abbreviated OVB, and so you'll often hear about OVB in like big regression studies. Like, I didn't have access to financial aid data, so there is some omitted variable bias in my estimates because I couldn't calculate how many students got a Pell Grant or whatever, for example. So it's kind of something you need to acknowledge, but you can't always control it. You can't always do too much about it. 2 more things real quick. I really do think that while there is kind of a lot in this chapter, the authors do it very well in terms of laying it all out. There's some discussion of, it says reading the printout or something, and I think what that means is when you get statistical output from a program, be it Stata, SPSS, Excel, whatever, you have to be able to interpret that output and not just have like the robots and the machines doing it for you. Because again, there's nothing more dangerous than somebody who knows how to push buttons but doesn't actually know what the information is that's coming back to them. So I would encourage you as you go through this chapter to really spend some time looking at those like SPSS output figures and tables in the chapter, and make sure you understand the narrative around them and the explanation of them. I also think the summary at the end of this chapter does a really nice job of really bringing together what you need to think about in terms of assumptions, in terms of generalizability, and can you extrapolate, and can you generalize any kind of finding, the omitted data piece, the extreme value piece, and all that. So yeah, that was a big chapter. So in 14 minutes, I tried to summarize that chapter. I don't know how well I did, but if you have any questions, let me know. And today is actually Friday, so I hope everybody has a great weekend, and I will see you all soon.